Hello students, welcome to Darasa Online. My name is Josia Moktalima. I'm a chemistry teacher, and for today I'm here to proceed with our discussion on the topic known as selected compounds of metal under the subtopic known as chlorides. So our topic is selected compounds of metal. And our subtopic is chlorides. And this topic is a continuation of your O-level topic which you studied, which is known as metal and its compounds. So for proceeding now, let us see now what are we going to consider in this subtopic. And the main issue that we consider in this subtopic is how can you prepare the metal chlorides, and also we'll discuss on the chemical properties of metal chlorides, and we'll also discuss on the peculiar characteristics of the chlorides of iron and the aluminium, and also the methods of preparation. And after that discussion now, we'll look on some questions and see how can we solve those questions concerning this subtopic. So if we now recall to our introduction that the metal chlorides when we talk of metal chlorides, we talk of the when a metal have combined with the chlorides or chlorides ion with chlorides ion or chloride atom. So the resulting compound here is what we call it metal chlorides. So since we are talking about the chloride ions or chloride atom, here is where now we can find the two methods of preparation of metal chlorides. So the methods of preparation of metal chlorides can be obtained from these two different forms of our chloride ions that combine with the metal. And here is that when metal combine directly with the chlorine atom or chlorine molecule, the resulting compound is the metal chloride. But that method is the direct method of preparation. But if a metal combined with chloride ions, which means that the chloride ions can be obtained from any compounds, then the resulting product will be the metal chloride. But that method is known as indirect methods of preparation. So preparations we have two methods. We have the direct method and the indirect methods. So we have the direct methods and the indirect methods. So if we start discussing about the direct method, direct methods involves heating a metal directly into chlorine gas is what we call it direct method. So you combine directly the metal and the chlorine. So here involves heating the metal directly in chlorine gas. Let us take an example of iron. Iron, which is solid, when heated directly in chlorine gas, when heated directly in chlorine gas, then the product is iron 2 chloride. And when balanced, the equation is balanced. But if chlorine gas is in excess, the resulting product is the reddish brown color product, which is iron 3 chloride. So when now this iron 2 chloride is further heated in chlorine gas, the product is iron 3 chloride, which is now the reddish brown color product. So this is what we call it direct method of preparation of chlorides of metal. Now when balancing, here we have 3, here we can put 3, then we have 6 chlorine, no, 2 chlorine, 4, there we have 3 chlorine, and you have here, we can put 3, then here it will be, it's your task, you can balance it yourself, you as a student, so you don't need to complicate it, so it's your task to balance that equation. Now other metal chlorides like aluminum and copper can also be prepared by the same method. So other metal chlorides such as of aluminum, and the zinc can also be prepared in the same way. When you say in the same way, that means heating these metal directly in chlorine gas. So let us consider for the case of aluminum. If this is aluminum now, our metal, when it directly heated in chlorine gas, then the product is aluminum chloride. So you can balance it, it's your task to balance. But also, if it's zinc, you can heat directly in chlorine gas, and the product is also zinc chloride. So these are what we call it direct method of preparation of metal chlorides. So let us now consider the second method of preparing the chlorides, which is now the indirect method. So we have the indirect method. Indirect methods here can be categorized into 3 categories. One is what we call it precipitation method, and second is the reaction of alkalis with dilute hydrochloric acid, and the third is the reaction of metal oxide with dilute hydrochloric acid. So the third is the reaction of metal oxides with dilute hydrochloric acid. Normally, the precipitation method is specifically a method of preparation for insoluble chlorides. Taking an example here, if you have precipitation method, if you have silver nitrate, then this one, if treated with a solution of dilute hydrochloric acid, the product here obtained will be silver chloride, which is solid, and the other product will be the nitric acid. And to balance is your task to do it. So this is what we call it precipitation method, since what we have obtained is silver chloride, which is our PPT or precipitate. Likewise, if you have lead nitrate, when also treated with dilute, this is aqueous, when treated with dilute hydrochloric acid, then you'll end up getting the lead chloride, which is solid, then plus nitric acid, which is an aqueous. So you can balance the equation. Now this is now our precipitate formed. So this is what we call it precipitation method. And we also have mentioned that the reaction of alkalis with dilute hydrochloric acid, reaction of alkalis with dilute hydrochloric acid. Taking an example of a very common alkali, which is sodium chloride, sodium hydroxide. When sodium hydroxide is treated with dilute hydrochloric acid, then you get our soluble chlorides, which is sodium chloride, then plus water. And it is a kind of neutralization reaction. So this is now our alkali reacting with the hydrochloric acid. The product is sodium chloride, which is now our chloride that we are talking about. But the third method you have talked about, the reaction of metal oxide with the dilute hydrochloric acid. Here, taking an example, so the reaction of metal oxide with the dilute hydrochloric acid. So if we take an example of calcium oxide as our metal oxide, this calcium oxide, when treated with the dilute hydrochloric acid, our product here will be calcium chloride plus water. So that is our product. Now, this calcium chloride is our soluble chloride that have been formed. So it is an example. So these are the two methods that can be used to prepare metal chlorides. We have mentioned that we have the direct method and the indirect method. So let us now move to another part, which is about the chemical properties of metal chlorides. So the chemical properties of metal chlorides. And here on the chemical properties of metal chlorides, we'll discuss on two main chemical properties, which is very, very important for you to understand. One, we'll discuss about the reaction with water, reaction of metal chlorides with water. And secondly, we'll discuss the chemical properties which about the action of heat. Action of heat on metal chlorides. Okay, my dear students, I think you are following. Now, let us consider about the reaction of metal chlorides with water. here normally the reaction of the metal chlorides of sodium and the magnesium with the water does not take place. What happens is that the metal chloride dissociate into their respective ions. So no reaction between water and the metal chlorides of sodium and the magnesium. So what is happening here is that sodium chloride, when reacted with water, they just form their aqueous solution, which means that they dissociate into their respective ions. So likewise, if it is magnesium chloride, also in water dissociate into their respective ions, so it exists in aqueous state, which is now magnesium chloride aqueous. So writing aqueous, that means they are ions. You can balance the equation. It's now your task, my dear students. So that is about the sodium chloride and the magnesium chloride. The other metal chlorides reacts with the water by the process known as hydrolysis. So the other metal chlorides reacts with water, and this process is known as hydrolysis. So let us take an example of our most common chloride, which is iron 3 chloride. So taking an example of one is iron 3 chloride. When reacted with water, they result into formation of, so let us take an example of iron. Take an example of one, which is aluminum chloride. When reacted with water, they result into formation of hexa aqua aluminum 3 ions, then plus 3 chloride ions. So this is an aqueous and that one is an aqueous. So that is what happening. So aluminum chloride get hydrolyzed into formation of hexa aqua aluminum 3 ions, which is our complex ion. Now, if by balancing there, here must be 6. Now, the iron 3 chloride proceed to react with water. The reaction now proceeds whereby the aluminum hexa aqua aluminum 3 proceeds to react with the water, resulting into formation of acidic solution, which is now you'll have the aluminum hydroxo penta aqua aluminum, then will be plus hydroxonium ion. So the hydroxonium ions which is released now indicates the acidic solution of aluminum chloride. So that's why you say that aluminum chloride in aqueous solution, it is an acidic solution. So that is what is happening to aluminum chloride. Likewise to iron 3 chloride also results into formation of acidic solution due to formation of hydroxonium ions. So you can balance the equation, it's your task to do it. Okay, another example is the zinc chloride, when it reacts with water, which is liquid, results into formation of zinc hydroxyl chloride, which is an aqueous, then plus hydrochloric acid, which is also an aqueous. So it's your task to balance the equation. So this is known as zinc hydroxyl chloride. So that is what we call it also hydrolysis. And if we consider another example, this is zinc chloride. If we consider another example of copper chloride, when copper chloride is reacted with water, undergoes hydrolysis, resulting into formation of a complex compound, which is copper dihydroxyl, resulting into formation of a complex compound of dichlorohydroxyl couplet 2 ions, which is now an aqueous. It's your task to balance the equation. So that is how the metal chlorides reacts with water, and that reaction is known as hydrolysis. Now from there, let us see another chemical properties of metal chlorides, which is now the action of heat on metal chlorides. So we have the action of heat on metal chlorides. Normally, most metal chlorides are resistant on heating. So most metal chlorides are resistant on heating, which means that they do not undergo decomposition on heating. But some metal chlorides, when they are in their hydrated form, then they are being heated, they undergo what we call it hydrolysis. But some metal chlorides in their hydrated form, when heated, get decomposed by the reaction which is, we call it as hydrolysis. When heated, undergo hydrolysis. Let us take an example of our hydrated metal chloride, which is magnesium chloride with 6 water molecules. So it is hexahydrated magnesium chloride. Taking an example of magnesium chloride with 6 water molecules, when heated, magnesium chloride undergoes hydrolysis, leading into formation of basic chloride of magnesium, which is this one, the basic chloride of magnesium. Then the other product is HCl and the water which escapes as water vapor. It's your task to balance it. So that is what is happening. So instead of removing water, it undergoes hydrolysis, leading into formation of the basic chloride of magnesium. And further heating on this product is that we have now magnesium, basic chloride of magnesium. When further heated, it results into formation of magnesium oxide, which is solid, then plus hydrogen chloride, which is an aqueous. It's your task to balance the equation. So do you see now how hydrolysis is taking place on hydrated metal chlorides? And that's why we say that hydrated magnesium chloride cannot be prepared. Hydrated magnesium chloride, anhydrous magnesium chloride cannot be prepared by heating directly the hydrated magnesium chloride. Why? Because it undergoes hydrolysis. So instead of forming anhydrous magnesium chloride, it results into formation of magnesium oxide, which is our end product. So no anhydrous magnesium chloride is formed. So that is what is happening in metal chloride when heated on their hydrated form. But you have another example, chloride of aluminium. The hydrated chloride of aluminium, when heated, releases the aluminium oxide, then plus the other product is the hydrogen chloride gas and the water molecules. So it's your task to balance those equations. So that is what is happening to the hydrated metal chloride. So likewise to aluminium chloride, iron 3 chloride, zinc chloride, hydrated form of zinc chloride when heated releases. But for zinc chloride, which have 2 water molecules, when heated releases zinc chloride, then plus water, which means that you can now prepare the anhydrous zinc chloride by heating the hydrated zinc chloride. Then now you'll have the product of our anhydrous zinc chloride. Because that wise is the same to that of copper chloride. Copper chloride, when heated, also releases copper chloride, then plus water, which escapes as a vapor or as a gas. Even here is a gas that escapes into the atmosphere. You can balance the equation. So that is about the action of heat on metal chlorides. So let us now consider how can you identify that these compounds contain chlorides or are metal chlorides. So we have what we call it the chemical test of chloride ions. So we have what we call it test for chloride ions, and this is applied in qualitative analysis. Do you remember qualitative analysis? So here we use silver nitrate. Silver nitrate solution is used to test for the presence of chloride ions in compounds. And here, let us consider the reaction behind. If it is silver nitrate and mixed with a solution containing chloride ions, then the resulting product is the formation of white PPT of silver chloride. So this appears as white precipitate. White precipitate of silver chloride are being formed. So this is now the specific reagent which is used in testing the presence of chloride into a substance. Now from there, let us now proceed with another part on which is about the specific characteristic of the chlorides of iron and the chlorides of aluminium. Chlorides of iron and the chlorides of aluminium. So apart from being the members of the metal chlorides, they have specific features which differ from other chlorides of these metals. And the first to start discussing is about, we have mentioned that these are metal chlorides. And here, for the case of iron and aluminium, they are chlorides. Their chlorides are covalent in nature. We know that when a metal combines with a non-metal, the resulting compound is mainly an ionic compound. But here, what is happening, the product which is formed when iron or aluminium react with chlorine, the result into formation of chlorides, which is covalent in nature. And what makes it to be covalent? This is observed due to their volatility nature. And apart from that, they also in their aqueous state, they are poor conductor of electricity, poor conductor of electricity in their aqueous state. And what makes it to be poor conductor of electricity in the aqueous state is that the chlorides of aluminium and the iron exist as molecules. And we know that molecules do not conduct electricity since there is no ions. And the ions are the only responsible particles for carrying charges from one point to another point. So since the chlorides of iron and aluminium exist in molecules, so that's why they do not conduct an electric current. And another specific characteristics that are exhibited by the chlorides of iron and aluminium is that when heated, when their solid state are being heated, they undergo what we call it demineralization. So second is that when their chlorides are heated, undergo what we call it demineralization, and they exist as dimers in their vapor state. So for example, if we take aluminium chloride, when heated, undergo what we call it demineralization, changes from solid state into vapor state, but in vapor state exist as dimers. So this is what we call it demineralization. This is dimers. So here, after balancing, here must be 2. Likewise to iron chloride. likewise to aluminium chloride. Aluminium chloride, when also heated, undergoes demineralization into vapor state. So it is aluminium chloride with that of molecular formula, and this is in gaseous state. So after balancing here must be 2. So that is the second specific feature of the chlorides of aluminium and the iron. But the third is that what we have also discussed, that in their aqueous state, they exhibit an acidic condition. So third is that they react with the water to produce an acidic solution. And here we have discussed about how aluminium chloride reacts with water to form an acidic solution. So here let us take an example of iron 3 chloride. This one, when reacted with water, undergoes hydrolysis to form the resulting product, which is our complex product of aluminium of hexa aqua, aluminium 3 ions, then plus 3 chloride ions there. So this is an aqueous. And the further reaction takes place for now aluminium hexa aqua iron 3 ion proceed to react with this is an aqueous, to react with the water molecules and resulting into formation of a complex compound of hexahydroxyl of and there are 2 positive, then will be plus the other ions that which is now the hydroxonium ions. The other product is hydroxonium ions, which is now indicates the acidic property of the chlorides of iron 3. So you can balance the equation if you are tasked to balance it. So that is now the third peculiar or special feature of iron chloride and the aluminium chloride. The fourth now is that they act as catalyst. They act as catalysts in different chemical reactions. And what makes them to be able to act as catalysts? This is due to their smaller size and the high polarizing power. And not only that feature, but also due to presence of vacant orbital. For the case of iron is D2sp3. This is for iron, and the sp3 for aluminium. So therefore here now the metal chlorides now can undergo oxidation or reduction, thereby now catalyzing different chemical reactions that they can be used. Do you remember we call them as Lewis acid? Very specifically, if you remember the knowledge of organic chemists on the reaction of benzene. So that is the 4 main peculiar features of the chlorides of iron and the aluminium. So from there now, we have now finished our part that I promised you to discuss. So let us now, after a short break, go and consider some questions that employ you to use the knowledge that we have discussed here and answer those questions and get the correct answer. So see you later. Okay, welcome back to some questions that now employ you to use the knowledge that we have discussed. Now, the first question is that comment on the following observations. Support your answer with a balanced chemical equation whenever necessary. And the first one is that the relative molecular mass of aluminum chloride in the vapor state is twice the expected value. Do you remember discussing the peculiar characteristics of aluminum chloride and the iron chloride? We talked about this one. So here it is about aluminum chloride. So for question 1 now, A is aluminum chloride. We are told that this aluminum chloride in its vapor state has twice the expected molecular mass value, which means that if twice, that means it's the dimerization of aluminum chloride, which results into formation of the dimer of aluminum chloride, which is now a gaseous state. So here when heated, this is what we call it, dimer of aluminum chloride. So that's why now, if now you find the molecular mass of the solid aluminum chloride, and that one which is in vapor state or in gaseous state, the molecular mass of this one is twice than this one. So that is our first part question, where we have been asked to support by using chemical equation. So this is our chemical equation that now supports that explanation. So it is because aluminum chloride in its vapor state undergoes dimerization. The second part, which is B, that anhydrous magnesium chloride cannot be prepared by heating the hydrated crystals of magnesium chloride. And here, I think you remember when we were discussing about the action of heat on metal chlorides. Here we talked about, for example, we talked about zinc, the hydrated form of zinc chloride that have 2 water of crystallization. So when heated, this is solid. When heated, results into release of zinc chloride, which is now solid. Then the other product there is the water vapor. You can balance. So this is now hydrated form of zinc chloride. By heating, you have obtained anhydrous zinc chloride. Here is 2. Anhydrous zinc chloride, you can balance it. So we are now asked the same question to what happened to the case of hydrated magnesium chloride. Will it give magnesium, anhydrous magnesium chloride? The answer is no. You remember we said that when magnesium chloride is in its hydrated form and when heated, instead of releasing anhydrous magnesium chloride, it releases the basic chloride of magnesium. So here, by using now equation to support that answer, is that magnesium chloride, which is in hydrated form, when heated, it releases the basic chloride of magnesium, which is magnesium chloride, this one. And the other product is hydrogen chloride. You can balance the equation if you are tasked to balance. But further heating, you may think of further heating. Further heating, this is a guess. Further heating of basic chloride of magnesium results into formation of magnesium oxide, then plus hydrogen chloride is a gas. So do you see at the end the product is magnesium oxide and not anhydrous magnesium chloride. So that is now how you are supposed to answer that kind of question. And the third part is that aluminium chloride does not conduct electricity. Aluminium chloride does not conduct electricity. So what does it mean here? It means that it cannot form ions in either aqueous state or in its liquid state, because the ions are the responsible particles for carrying charge from one point to another point. So since aluminium chloride does not conduct electricity, this is due to covalent nature of aluminium chloride. We have discussed that the aluminium chloride is covalent in nature. So in aqueous state, it exists as molecules. So if it exists as molecules, molecules cannot carry charge from one point to another. So that's why aluminium chloride does not conduct electricity. So that is about question number 1. So let us now go and consider question number 2. Question number 2 is that iron 2 chloride forms a light green solution when dissolved in water. Its color changes to reddish brown when exposed to air for some time. Then why the color of the solution changes when exposed to air? Support your answer with a balanced chemical equation. That is simple, my dear students. I know you remember. Iron 2 chloride is this one. This is iron 2 chloride. Forms a light green solution when dissolved in water, which means that when reacted with water, do you remember hydrolysis? This now will result into formation of hexa aqua aluminium 2 ions. Then it will be plus chloride ions, which is an aqueous. So balancing there must be 2. So which means that with the supportive balanced chemical equation, so you can balance the equation. If we balance here must be 6. So this is what appear to be light green solution. But later on, we are told that its color changes to reddish brown. That means from light green to reddish brown. But when it is when exposed to air, which means that we have an air here. When exposed to air, and here the reddish brown color is the color of aluminium, is the color of iron 3. So which means that here it is an oxidation reaction whereby iron 2 is being oxidized to iron 3 ions. So that is the oxidation reaction which is taking place. So in air, iron 2 is being oxidized into iron 3. That is an oxidation reaction. So you can write the complete reaction. It's your task also to do that. So that is about question 2, what it was supposed light green. Then this is our reddish brown solution, which is that of iron 3 chloride. Now from there, it's now your task to do the following questions as an assignment, my dear students. I'm sure you can do it very simple because we have discussed the knowledge. So let us now go to your assignment, which is now this one. It's question number 3, but it's the first assignment to you. The question is that how can you identify the presence of chlorides in a solution. Support your answer with a balanced chemical equation. That is the first assignment question. How can you identify presence of chlorides in a solution? Support your answer with a balanced chemical equation. And another assignment question, which now will be question number 2, is that under certain conditions, iron reacts with chlorine to give anhydrous iron 3 chloride. Then why excess chlorine used? You have to give an explanation. B, moisture should not be allowed into the apparatus during the reaction. Why moisture should not be allowed into the apparatus during the reaction? And the C is that why iron 2 chloride is not formed. So that is another assignment question that you need to do it. And after doing it, you can contact through my number or WhatsApp number, which is 0713 14 09 14 for consultation, for confirmation of the answer that you have obtained. Thank you very much. I'm sure you have enjoyed the lesson, and this is the end of our lesson today. So see you next period.